Hello everyone, welcome to the session on geniuschalk. Today I will be discussing HCF LCM last part. It is going to be part 6 where the remaining type of difficult questions I will discuss. So let's start the session. Let x be the least number divisible by 16, 24, 30, 36 and 45 and x is also a perfect square. Then what is the remainder when x is divisible by 123? So first, take the LCM of all of these. We know how to take the LCM. What is the highest power of 2 available here? We can see there is no 32. So highest power of 2 available is 4 because it is 16. Now what is the highest power of 3 available? 3 is in 36, that is 9, right? Then highest power of next prime number, that is 5. 5 is only present once. And x is 9 is 3 square. This is 2 to the power 4 and this is 5. It is also saying that x has to be a perfect square. If it has to be a perfect square, here perfect square means power is even. Power of 5 is 1. That is not even. So I'll make it even by multiplying with 1 more power of 5. Now it's a perfect square. We have to find the remainder when this is divisible by 123. 123. Now, what is it? If you see, this is 16 into 9 into 25 basically, and 123. So first of all, let's make it short. We can cancel this. It is 3 4s, 3 1s, and 3 3s. This becomes 48, right? When 48 is divisible by 41, and second case 25 is divisible by 41. So this becomes plus 7, right? So, and this becomes 25 into 7, that is 175. If you divide it by 41, it will be going 41 4s are 164 and it becomes 165. So 11 will be left. So 11 will be left. But remember, as per division rule, this was 123. We had cancelled it and we had made it 41. So we had divided it by 3. So in the end, I need to multiply this 11 by 3. So that is my answer. That is option B, right? Let's try the next one. X be the least 4-digit number, which when divided by 2, 4, 3, 5, 6, and 7, leaves a remainder of 1 in each case. If X lies between 2800 and 3000, then what is the sum of the digits of X? Now, first thing, let's find the LCM of all of these. So let's check the highest power of 2 available. That is 2 square. That is 4. Highest power of 3 available. There is no 9. So it has to be 3. Highest power of next prime number. That is 5. And one more number, which is prime. That is 7. So this is the number which we have. Now, after this is 7. So now divisors are leaving remainder 1. So this is complete into n plus 1. And now there is a range given that X lie between 2800 and 3000. So let's find out what value is coming actually. This is 4 3s are 12, 5s are 60, 7s are 420. So 420 n plus 1 is the form. Here I need to put some value of n, after which I can come closer to this range. So 4 7s are 28 and this is also 2800. So minimum value I can put is 7. So let's put n as 7. If I put n as 7, I'll be getting 420 into n, that is 7 plus 1. And this becomes 7 2s are 14. It is 2940 plus 1, that is 2941. This is the number, and you can see very clearly that this number is coming in this range. What is the range? 2800 to 3000. This number is coming in this range. So what is asked? The sum of the digits. So sum of the digits is 9 plus 2 11, 11 plus 4 15 plus 1 16. So my answer is going to be option A, right? Okay, let's solve one more like this. So the numbers divisible are same, like the numbers by which the number is divisible, they are same. So I'll be getting, and this time 6 also. So highest power of 2 available is 2 square. Highest power of 3 available is 3 only. Highest power of 5 is 5 only. and we have 7. So again, 4 3 are 12, 5 is 60. This is 420, and remainder is 1 in each case. So 420 n plus 1. But this time the range is different. What is the range between 2000 to 2500? This is my range. So I have to work accordingly. So put the value of n. Earlier I put 7. Let's try with 6 because the number is less now. The range is less now. So it has to be 420 into 6 plus 1. That is 2520 plus 1. That is 2521. But that is 7 plus 2, 9 plus 1, 10. So answer is 10. Option C. Right? Next one. Leaves the remainder of 4 and the numbers are 8, 9, 12, 14 and 36. Let's see what is the highest power of 2 available. There is no 32. So highest power of 2 available is 3. Fine. What is the highest power of 3? So in 36 it is 9 also. So 9 means 3 square. After that, highest power of next prime number. 3 is there. 2 is covered. 3 is covered. This is 3 into 4, both covered. Next is 7. 7 into 2, right? And rest I have covered. So this is my LCM and leaves a remainder of 4. So it has to leave a remainder of 4. And x is divisible by 11. Now it says that this complete number is divisible by 11. Then the sum of digits of x. Now here we can apply one shortcut that you can find like this also. Like this is 8 9 is 72. 72 into 7. That is 504 n plus 4. And this is divisible by 11. And this value we need to find. So we can directly divide by 11 also. And we can solve like this also. In this, 9 is there. 9 is one of the factors. That means here also it must satisfy. This 9 must satisfy this condition. So here you can see this number is already divisible by 9. So 9 plus 4 is 4. So digital sum has to be 4. And when you divide 4 by 11, then the answer is also coming out to be 4. And the next, we can cancel it like this. So here there is no need to think. Answer is 4. Another way, if you solve like this, 11 4s are 44, 6 4, 11 5s are 55, 64 and 55. Again, you can see the same thing is coming. It is coming as 9n plus 4. And 9n means this number is divisible by 9. And after that, it is 4. So when the number is divisible by 9, in that case, the digital sum must be a multiple of 9, right? So after that, it is plus 4. So the sum of the digits must be plus 4. Or you can put it like this, 9n plus 4, right? This is the equation. Now, what value I should give here to n? So that it is divisible by 11. So what is the least number? 11. That is 11 only. If I do like this, it is in decimal. Next 22. So this is 22 minus 4, 18. So n value will be 2. So this n value has to be 2. So this is basically the complete answer has to be 504 into 2 plus 4. And this is going to be 8, 1008 plus 4. And I've told you this is digital sum is 9. And if digital sum is 9, it will always be divisible by 9, right? So it has to be 8 plus 1, 9. So 9. And what is the answer? Basically, you see 1012. Now, what is the digital sum? 2 plus 1 plus 1, that is 4. So you can apply with the basic approach also, and you can apply using this that, okay, 50n plus 4 has to be divisible by 11. And this 504 is divisible by 9. So the answer has to be 4. This remaining one is 4. Else you can directly solve like this, like we have done. And in that case, it is again 9n plus 4. So 9 multiplied with any number, digital sum is always 9. So the remaining has to be, see, if you divide with, if you divide any number with 9, suppose you divide 23 by 9. So it has to be 9 to 18 and it is 5. Like this. So it is in this form, 9n plus 4. That means when you're dividing the number by 9, it is giving you 4 remainder, right? So, or That is also possible. 9 into 1, 9 plus 4, then 9 into 2, 18 plus 4, same remainder. Every time you divide by 9, remainder will be same. That's why we are following this approach. All right. Next one, the number between 4,000 and 5,000 that is divisible by all of them. 12, 18, 21, and 32 is this. Okay, fine. So let's find the LCM first. 2 to the power 3, that is 8. And after that, 3 to the power, it's not 2 to the power 3. 32 is there. It has to be 2 to the power 5. Okay. And like this, you can solve. 7 is also there. Yes. And 4 and 3 already there. So one thing is like this will be of this form, right? Some multiple of this. So this has to be 32 into 9 into 7, right? This form. So basically we can see that this number is divisible by 32 also, by 9 also, and by 7 also. So just check which number out of the given options is divisible by any one of them, which is easier to solve. So first let's take 9, which is very common. So for 9, the sum of the digits has to be 9. This is 5 plus 4, 9. This could be our answer. 4 plus 2, this is also 9. This could be our answer. And this also, and this also. That means 9 is not working in this case, as all the options are coming. Afterward, the second weapon we have, that is we can use 7. So multiply with 7. So what is the rule for 7? That take the pair from the last, and it has to be 203 minus 4. And what is that? It is 199. Is 199 cancelled by 7? So 19 minus 18. 9 2s are 18. It's AB minus 2C, right? This is the rule for 7. Take the first 2 digits and minus double the last. It is 1. It is not divisible by 7. So this is not my answer. If you take 4023 and take its pair, that is 23 minus 4. That is again 19. So 19 is not, divisible by 7. So this is not my answer. Afterwards, 4032. So it is 32 and 4. If you subtract, it is 28, and 28 comes in the table of 7. So this has to be my answer. If you check this, 302 minus 4, again, this is 298. 29 minus 8 double 16. This is coming out to be 3 and 1. So this is also not divisible by 7. So just by the divisibility of 7, without solving this number completely, we are getting our answer, right? So this approach, divisibility, which we have studied in the number system, is very, very important. All right, next one. What least number must be subtracted from 1936 so that the resulting number, when divisible by this, and this, leave in each case the remainder 7, right? So what least number must be subtracted from 1936? So you have to subtract something from this, and whatever number is there, that is divisible by 9, 10, and 15. So let's find the LCM first. Highest power of 3 is 9. Then we have 5 also. And then we have 2 also, I guess. Yeah, 2 is also there. So highest power is LCM is 90, right? So the number will be of the form 90n plus 7, because in each case, it has to leave the remainder of 7, right? In each case, it has to leave the remainder of 7. If you subtract, now in this question, just use the options wisely, because if you solve like this, it will be putting values of 9 and it will be taking time. So what I'll do is, I'll use the options effectively. So first is, if I subtract 1936 and I subtract 37, I'll be, left with, this is 9, and 36 minus 7, 1899. And is this divisible by 9, 10, and 15? Just check. So is this divisible by 9? Yes. Is this divisible by 10? Yeah, it has to leave remainder 7 also. That is also we have to make sure. So for that, basically, we can pick anyone, like 9 divisibility plus 7. So it should leave plus 7 after divisibility of 9. So it is completely divisible by 9. This could not be my answer. If I take 36, If you take this 36, it will be 1900 completely. Huh? And if you divide it by 9, it is giving you something divisible by 10 also. It is divisible by 10, right? And divisible by 15, we have to check. So if you divide it by 9, LCM we have got 90, right? But let's check it by 9. It is not divisible by 9. How much is leaving? 18, 10, 10. Remainder is 1. So it is also could not be my answer. Now go to the third option. If I subtract 39, 16 minus 9, this has to be 1897. Now just check 9 plus 9, 18 plus 7. Yeah, this is if something is divisible by 9, remember the digital sum should be the remaining one, 7. And this is giving us digital sum 7 because this is divisible by 9, but digital sum is 7. So this is my correct answer. So what I am doing is I'm just using the divisibility rule of 9 to solve all of these questions because for divisibility rule of 9, the digital sum must be 7. Must be 7 in this case. This is completely divisible by 9 and remainder is also 7. So third option is my answer. And if you want to check 1936 minus 30, so this becomes 1906. Again, you need to check 9 is there, but digital sum is again 7. Digital sum is again 7. So let's check 1906. But it is saying what least number. So, it could be possible that 30 could also be there. So let's check because 30 is least than 39. Let's check by all. Is this divisible by 10? Just check. It is divisible by 10. No. And it is leaving remainder 6. If you divide it, it will be 190, 19 times. And then remainder is 6. We need remainder 7. That's why this is not my answer. Answer has to be option C. That will verify all of them. Right? 1897. If you check 1897. If you divide it by 10 also, it will leave you remainder 7. If you divide it by 15 also, let's check whether it's verify or not. Because sometimes only 9 will not work. In this case, it was also divisible by 9. We have to check with 10 in this case. So 3, 9, 15, 2 are 30 and 97, 15, 6 are 90. We can see that it is also giving us remainder 7. So option C is my correct, accurate answer. All right. What is the greatest number which of 5 digits divisible by 3, 5, 8 and 12 leaves 2 as the remainder? So this is 2 to the power 3 and 3 is there highest, then 5 is there. Yeah. So 8 3s are 24, 5s are 120. Now 120 n plus 2, this must be the form. And it has to be greatest number of 5 digits. So what we'll do is we'll directly check the divisibility. 3, 5, 8 and 12. Fine. And remainder is 2. If you divide it by 3, it is completely divisible by 3, no remainder. And it is also completely divisible by 3, no remainder is coming. We have to have remainder 2, right? It is giving 2 remainder and it is also giving 2 remainder. So these two options could be my answer. Divisible by 5, giving 2 remainder, 2 remainder. Divisible by 8, 8 9 yes, giving 2 as remainder. 8 giving 2 as remainder. Divisible by 12, let's see, 12 is 96, fine. 12 6 is 72. So both are giving, both are satisfying all of the options, all of the divisibility rules. But it is saying greatest number. So which is the greatest one? I will pick option C as this is the greatest number, 99962. Greatest number. Although this is also satisfying all the conditions, but I have to go with this option. And further, I have discussed the way which you can solve, like divide it, 999, 5 digits and divide and get the remainder, then subtract the remainder. You will get the same answer, right? Remainder must be 38 in this case. That's why you subtract 38. After solving it, you can give the answer in comments whether you are okay with this method or not, right? Let's discuss next one. Least multiple of 13 divisible by dividing by 4, 5, 6, 7, 8 leaves remainder 2. So this is 2 to the power 3. This is 5 and this is 5 and this is 7, right? This is 8 5s are 40, 40 into 7 280. Fine. 280n plus 2. This form I require, and it has to be the least multiple of 13. Let's find it. This has to be the least multiple of 13. We have to find the least multiple of 13. So let's check whether this is least multiple of 13 or not. So either you can check it from here, like 13 ones are 13, and this is 150. So 13 twos are 26 now. So 20. So 7n plus 2 is coming. Now, if this 7n plus 2 is divisible by 13, what value I should give here? It should be divisible by 13. So just tell me which value we can give. If I give 13, it will be 11, not divisible. 26 minus 2, no. If I give 39, 37 by 7, no. If I give 52, no. And if I give, so we can see that if I give 65, 63, yes, then it will work. So if I give 65, 7n plus 2, so n will be 9, as it is 63. So n will be 9. After putting this n as 9, we'll have an answer 280 into 9 plus 2. So we can see that 9 zeros are 0, 9 8 is 72. 18 plus 5, it is 18 plus 7, 25 plus 2. So right answer is 2522. So logically, you can solve using this method, and directly you can solve without using this method. Just check which number is multiple of 4 and leaving you remainder 2. So this is not this option. This could be, but if you divide by 5, leaving remainder 2, this is fine. Divide by 6, fine. 7, fine. 8, yes, fine. So this is also fine, yes. But is this a multiple of 13? 13, 6 is 78, and this is 62. It is not a multiple of 13. This could not be my answer. The first priority in this question has to be, we have to find least multiple of 13. If we find least multiple of 13, our things will be easy. So this is the right answer. It is also a multiple of 13, even if you divide this by 4, 5, 6, 7, 8, as we have got it already. So there is no need to prove. Just divide and check whether it is giving the remainder 2. And it is already divisible by 13. 13 to the 26, and so on. You can divide it and check. So answer has to be option C. So we are using divisibility approach to solve all these questions. Least number divisible by 18, 27, 36 separately, leaves remainder this separately. So we know the trick. Divisible by 18, divisible by 27, divisible by 36. The remainder is 5, remainder is 14, remainder is 23. This has to be 13. This is also 13. This is also 13. So the correct approach has to be LCM minus this difference of divisor and remainder. But we can try using other approach. So let's try. If I find this, there is 9 here, hai na? What is the LCM? There will be 9, and then 3 square. Basically 9 goes to 27. Then 2 square 4. So basically it will be 27 also is there, which is denoting 9, and 4 is also there in all of these options, as 9 4s are 36. So 9 2s are 18. So after that, 18 minus 5, that is 13. 27 minus 14, 36 minus 23. So this is LCM minus 13. We can solve it. So 27 4s are 108. 108 minus 13 is how much? 95. The first option is my answer. Or you can find another approach, that just check. 18 has 9, so just check whether 95 is divisible by 9. Yes. Leaving remainder 5. Yes. Is it divisible by 27, leaving 14? Yes. So it will satisfy all of the options. That's why this is my correct answer. If R is the remainder, when each of 4749, 5601 and 7092 is divided by the greatest possible number D, whose value is greater than 1, then find the value of D plus the remainder also. So basically, greatest number possible is the HCF. So first, let's find the HCF of all of these. And we know the shortcut. HCF is always, for bigger numbers, the difference or the difference of their factors. So let's find the difference. So this becomes 11 minus 9, 2. 9 minus 4, 5. Then 15 minus 7, 8. Write the difference here, 1. Then 9. Then this is 4. and 1. And the third and the first also. This becomes 3. This becomes 4. And this becomes 2, 3. So now we have to find the HCF of 852, 1491 and 2343. So let's find their HCF, as HCF would be the factor or their difference only directly. So let's find, for this, let's check the above two. Let's use division method as numbers are bigger. It will be going one time. So this becomes 5, this becomes 8. And this is also 852. So what is the HCF? 852. Is it? What is the HCF? 852. But check once again. The concept says that if 852 is the HCF, it has to cancel all of them. And you can see it is 2, 2 never ends with 1. So 852 is not my HCF. Right? So now write some factors of 852. If I write 4 as a factor, this will be left with 2 because all the options are nearly in 200. So I can assume that 4 has to be some factor. So 4 2s are 8 and 1 3. Now just is it divisible by like does it divide all? So 2 1 3. If I check for 1 4 9 1, let's check 13 7s are 91. So it is completely divisible. Yes. And if I check for 2 3 4 3, let's check 2 1 3. This becomes 2 1 3. This is 1. This is 2, and it is also divisible. That means it's a good question. The HCF has to be 2 1 3. HCF has to be 2 1 3. If HCF is 2 1 3, and now we can solve. HCF is 2 1 3. So now divide. 2 1 3 is my HCF. Now divide anyone. 4 7 4 9. Yeah. If you divide 4 7 4 9, and there will be some remainder coming. So it is 2 times approximately 426. This is 8. This is 489. Next is, I guess, 2 times again, 426. This becomes 3. This becomes 6. So 63 is there. So 213 plus 63. What has to be my answer? It has to be 276. A beautiful question and a beautiful concept. So not only you have to find HCF, you have to find a remainder also. After finding the HCF, divide that particular any number by the HCF and then find the remainder as well. As it is the greatest number, leaving remainder as well, right? That's why we have to find the remainder. Let's do one more question. When this number divided by the greatest possible number x. So let's find 3 7 3 8 5 6 5 9 and 9 5 0 1. Let's find the difference first. So greatest number, so difference 9 minus 8 1, 5 minus 3 2, 6 minus 7, 16 minus 7 is 9, and this is 1. Except 1 9, it is 2. 11 minus 9 is 2. Then 9 minus 5 is 4. Then 14 minus 6 is 8. And 8 minus 5 is 3. And the last is the difference. This has to be 1 minus 8, 3. Now, this is 1921. Now, I need to verify 1921 for 38, 42. It is also 19 to the 38, 21 to the 42. It is also going. So what is my HCF? It has to be 1921. So my HCF has to be 1921. But again, I need to check it whether this is dividing all or not. So does it divide all? 19 to the 38. And it has to leave some remainder also. Hai na? In every case, it has to be same. So what was the difference? I'll again write 1921, and this was 2. Then 9 minus 5, 4. Then 14 minus 8, 14 minus 6, 8. 8 minus 5, 3. And the last one, This is 3. This was 10 minus 3, but now it's 9. Now 14 minus 7, 7, 8 minus 3 is 5. Yeah, yeah. So does it divide all? Yes, it divides all these differences, fine. But does it divide these numbers? That we need to check. So let's check 1921 and 3738. It will go one time. So 3738. And remainder in each case is this, because 19 to the 38. So it will not go 2 times. It will go only one time. So what is the difference? 7, 1. 17 minus 9 is 8. 1817. 1817 is what we are left with. Now let's check if this is the proper HCF. It must give the same remainder in the second case as well. 1921 and 5659. 19 to the 38 and 21 to the 42. 7181. Yes. So it is giving the same remainder. That means this is my answer. So what is my answer? X is 1921 and remainder is 1871. So this becomes ending with 8. Only one option is ending with 8, and that is 3738. That has to be my answer, right? So this type is very, very important. Next, LCM of 165, 176, 385, and 495 is K. When K is divided by the HCF of the numbers, the question is P. Find the value of P. Fine. So let's find the HCF first. So 165 cancel by 11. 11 ones are 11. 11 5s are 55. So 11 into 5 into 3. Next, 176. It is cancelled by 4 also. And 4 4s are 16. 4 4s are 16. That is 4 into 4 into 11. That is 2 for 4 into 11. Next is 385, which becomes cancelled by 5. 5 into 7, 7. So this becomes 5 into 7 into 11. And what is 495? 5. 9s are 45. 9s are 45. 5 into 9 into 11. Right? So this is 3 square. So what is the LCM first? Let's find the LCM first. Highest power of first prime number 2, that is 4. So 2 to the power 4. Then next prime number is 3, which is 3 square. After that 5, and after that 11. This is my LCM. Now when K, this is my LCM, is divided by the HCF of the numbers. Now can you tell what is the HCF? Yes, we can identify the HCF. See, 11 is everywhere. 11 is everywhere. So HCF is 11. So the quotient we have to find. So 11 is cancelled. This is my question. That's it. So it is 16 into 9. The quotient is P. Divisible by 11. We can see 11 is everywhere. 11 is everywhere. Yes. There is no other number which is present everywhere. So we can't figure out. HCF has to be 11. So 16 into 9 into 5. So this becomes 144 into 5. Or this becomes 140 into 5, 700. And 7 here. Okay. I have missed 7 here by mistake. This is 7 again. Yeah, I missed 7 here. So this must be 7. So 720 into 7 is my answer. And that is 720 into 7 is 5040. 5040 is my answer. I just skipped this 7 actually. So in LCM, this 7 will also come. Rest 11 cancel. Just multiply all of them and it will be 5040. The next question, the sum of biggest 3-digit number and smallest 4-digit number whose HCF is 23. So biggest 3-digit number is 999. And if you divide it by 23, It will be 23 4s are 92. It will be 79. 23 3s are 69. That is 10. So the number has to be 989. As 10 is the remainder, if I subtract this, this will be completely divisible. Now, what is the next smallest 4-digit? Just add the next multiple of 23. If you add 23, it will be the next multiple, and this number will obviously be, after addition of 11, it will be a 4-digit smallest number in 1000 form. So it will be 23. So this will be 1012. So what is the total? It is 2001. That is option D. Next question. In finding HCF, now this is a new type. In finding HCF of two numbers by division method, the last divisor is 17 and the questions are 1, 11 and 2 respectively. What is the sum of the two numbers? It's a very good question. It's a reverse of what we have learned. And it is, in HCF, the basic method, it is asking about the basic method. What is the basic method? Basic method is that we use division method for the basic one. So let's try. Last divisor is 17. So if last divisor is 17, that means it must be giving me 0 remainder. Last divisor this, and the quotient are 2. So the last quotient is 2. That means this number must be 34, right? And the logic of HCF, once we divide and then we get the remainder, then whatever divisor was there, that comes here. That means here, in the earlier case, 34 was my divisor. And what was the quotient? Quotient was 11. So quotient is 11. So 34 into 11. And is 70 to the 34, fine. So 34 into 11 is 374, right? And 34 into 11 is 374. And there is something left, right? There is something left. That's why, and this left part has to be 34 only. Sorry, this left part has to be 17 only. Why 17? Because 17 is coming in the divisor next time, right? So this is here. Now 374 plus 17, it has to be 391, right? 7 plus 4, 11 and 9. So this is 391. I hope you're getting my point. What happens is, like, this is the division method. If the last divisor is 17, right? If the last divisor is 17, that means it is giving me 0 remainder. That's why this is the HCF. And this is giving me remainder 0. And the question last is 2. So 17 to the 34 plus 0 is 34. Now, this 17 must be the remainder in the previous case. So 34 into 11 plus 17 must be 391, right? 391. And before this 34 must be my remainder. That's why this is shifted here, like this 17 is shifted here, right? Divisor, remainder is shifted to the next as divisor. So this is 34. Now, what is the new, next one? So it is 34 is there, fine. And the quotient is 1. So 391 is there. And 391, 34 into 11 plus 70, that is 391. Now 34 is remainder, it is coming over here, right? So what we say, 391. So this number must be 391, right? You can see 34 is coming here in the dividend. So this number must come here after this. So this will be 391 into 1 plus 34. So this will be 9, it will be 400. And 34 minus 9, it will be 25. So 425. I hope you're getting my point. What is happening? Again, I try to repeat. When we take the HCF, you see 391 into 1 plus 34. Is it 425? Just check. 9, 3, 12. Yes. Then 34 will come in the divisor form. Then the next question is 11. So 34 into 11 and the remainder is 17. So 17 will go here. So that means on finding the HCF of two numbers by division method, the questions are 1, 11 and 2. What is the sum of two numbers? So the numbers are this one, I guess. What are the numbers? 391 and 425. This has to be 816. That is option C. It's a good question. Good question. What is happening actually? Start from the last divisor, that is 17, and the last quotient is 2. So 72 is 34, giving remainder 0. Afterwards, we can switch back. This is 34 will be going here in the previous divisor, and the next quotient was 11. So 34 into 11, and this 17 is coming. That means 17 must be here in the remainder. So 34 into 11 plus 17 is 391. Then 391 must go here, and it is 391 into 1 plus 34 should be here. So our two numbers were 391 and 425, whose sum is 816. Let's solve this. In finding the HCF of two numbers, the same type, let's try. The last divisor is 49. Fine. So it is like this. First time division, then some remainder has come, or I'll write it this side. First time division, then some remainder has come. Second time division, then some remainder has come. Third time division. This is what it is happening. So last divisor is 49, and the last quotient is 2. That means this, and because the last divisor is 49, that means this must be the HCF. That means this is 49 into 2. The remainder must be 0. And now this 49 must be left here in the remainder. That's why this is coming here, right? Now, before this, the quotients are 17, 3. So the quotient is 3, right? Now, 49 is there in the remainder, and it has become the divisor. And this is 98. That means 98 must be present here. This 98, which was divisor, now it is a dividend. So 98 into 3 plus 49. What is that? So 100 into 3, 300 minus 6, 294. 294 plus 49, which is the remainder. So this becomes how much? 3 and 294 plus 6, 300. 343. So 343. So basically here, I will write 343. 343. Now this remainder is 98. So what is the quotient? Quotient is 17, right? Quotient is 17, and this 343 must be here, right? And this 98 must be remainder. So 343 into 17 plus 98. Let's solve it. 17 3s are 51. 17 4s are 68 plus 5, 73. 17 3s are 51 plus 7, 5831 plus 98. That is 12. 5929. This number is 5929. That means we started taking HCF of these numbers, 343 and 5929. So I'll write it here, 343, 5929. So this is my answer. B is my right answer. So thank you so much for watching. That's all. Now your chapter is over, and you can focus on other chapters. So thank you so much for watching.